Now, in this problem, we're considering a car, and this car is driving through a bank curve, and the radius of curvature of this bank curve is r, and we're also given the banking angle theta that the curve has with the horizontal. And finally, we're also given the static friction coefficient with the car on the road. So the car is driving to this curve. As the car drives through the curve, it can either slide up or slide down. So if the car starts sliding upwards, then that means the friction force is going to be pointing towards the center of the curve, so like this. If the car starts sliding down, though, the friction force is going to be pointing away from the center of the curve. So we have to consider both cases. So basically, in one case, the main difference between both cases is the sign of the friction force. So in this free body diagram, we have all the forces that are acting on the car. We have the normal force, we have the friction force, and we have the weight of the car. So remember, to use one of the cases, the friction force can also point downwards, also towards the center. It depends on which way the car is sliding. So remember, the friction force is always given by mu s, the static friction coefficient, times the normal force. So we consider the radial axis. So first we have n sine of theta. So it's plus minus. We do this to be able to consider both cases. So a plus means that the car is going up, and a minus means that the car is sliding down. So friction force cosine theta. That's going to be equal to mv squared over r. And on the vertical axis, we have something very similar, just the sign is flipped. Now it's a minus plus. It's going to be equal to the weight of the car. So in order to find the velocity of the car, what we're going to do is we're going to divide these two equations and write the friction force using this definition here. If we do that, we're left with this relation, and it's straightforward to just solve for the velocity from here. We're left with, so from this equation here, we can just do some trigonometry to make things a little bit cleaner, and we're left with this equation here. So now, the minus sign corresponds to the smallest possible speed. So remember, when we have a plus here, we have a minus here. And when we have a minus up here, that means we have a plus down here. So we want to make the minimum velocity. In order to do that, we're going to take the case where there's a minus here and a plus here. That's going to be smaller than the other case. You can confirm it numerically by yourself if you want to be convinced. And so in order to make the minimum velocity 0, that means we have tangent theta minus mu s that has to be 0. And the way for that to be 0 is for mu s to just be equal to tangent of theta.